Okay, so this is part 4 of exercise 3 in chapter 2 of the Advanced GIS book. In this video, we're going to look at creating contours from both high resolution topographic data and like a 30-meter data set. Just to save time, I'll do that processing over the window that we're looking at here. So Contour is a tool that you'll find within the Surface Tools of Spatial Analyst Toolbox. Of course, you can also search it up here. So if I open that up again, all of these surface tools are having to point at digital elevation models. So we can create that high resolution lidar contour like this. So we can do contour of lidar. When you do a contour map, you're not producing another raster. You're producing line files essentially, so polylines and of equal elevation. And so you have some choices to make. What is your base contour? What's the lowest contour? Um, and then what's the contour interval that you're going to use? Now, with a really detailed high-resolution topographic data set, like we're looking at here, you could produce a really small contour interval. But the more lines you have to draw, the more your computer is going to bog down in drawing those lines. It's actually more expensive graphically to draw vector files as compared to raster files. And we've already seen that it has a bit of an issue drawing some of these rasters on my computer here, which is actually a gaming computer. So you want to be careful about, using half-meter contour intervals when you don't need to. And so, like, we could, for instance, here we could choose, say, a 3-meter or a 5-meter contour interval. Let's try 5-meter. And there's this other tool, right? Maximum vertices per feature. So that would be one way to like stop your computer from having to draw so many things by not allowing it to produce so many vertices or kind of junction points of bends. And that will, of course, smooth your contours and create artifacts, but could be useful. Contour type, contour. You can also choose them as polygons instead of lines. So let's run this, but now let's do the extent of the area that we're looking at here, and we'll run it. So we're producing a 5-meter contour data set over the area of this alluvial fan near Bicknell, Utah. And this was using the LiDAR data, okay? Now, this can be a pretty useful data set. It tells us for sure there's an alluvial fan here, there's high relief up there, we could label the contours. You can combine them with hillshade images or the aspect slope shade we were using. You might not like when you're looking at contours to see these big bold things. There's a couple ways to make those a little bit less harsh. You can go to properties and make them, say, white. Apply. And they kind of don't stand out so much in this shading. Or you could make them black or kind of dark gray, but thinner, like 0.25 points. And then they're kind of really subtle in there. And again, you can, let's save that. So some other ways we can, add robustness to these contours, right, is to actually label them. We know it's a 5-meter interval, but what are the values could be quite important to us. So can say label. And now label what though? it doesn't seem to be labeling the right thing. So then you go to label properties, and you want to label not the feature ID, but the contour, and apply it. Okay, and then there's choices about how you label and how many labels you put on there. And so it's kind of like following this drainage up here, and these are in meters above the datum. Yeah, so that is getting some contours on the map with lidar, and so those lidar contours should be pretty good. Now I want you to be a little bit cautious about using lower resolution data to make contours, because they're not necessarily going to be that good. So let's see that. So if we go to we go back to analysis and to tools, into contours. Oh, and by the way, if you just want to do one single contour, that would be contour list. You can input the raster and output contour line features, and then you can have different contours shown. And like if you only want to have like one contour that's really important, like on the Wasatch Front, it could be the contour elevation of the Bonneville shoreline or something, just as a reference point for elevations. That's an option as well if you don't want all contours showing up. But yeah, if we go back to contours and we go to the regional DEM, and if we do a 5-meter contour off of that, let's see how different the result looks. Okay, so I think you can see which one's which because of the different sizes, but you know, hopefully you see that there's a very different result going on there. You can kind of sense where channels are, and it's not very wrong or incorrect to use these 30-meter DEM based contours, but it might not be quite as accurate as you want. And it's probably not actually as accurate as some of the contour maps that you could get from the USGS, which were based upon surveys over decades of survey work. And so, yeah, anyways, easy to produce those type of contours, but not necessarily as robust. Certainly wouldn't you want to use it if you were planning an engineering project or something like that. Okay, yeah, so we've made contours, compared different resolution DEMs and the contour results. We showed how to label contours and how to make them a little less obtrusive in your imagery that you might print out and map on in the field, or put on a digital tablet and map. Yeah, so those can be quite helpful. So that's that video, and that wraps up kind of some of the basic derivative products from DEMs. We looked at hillshade, we looked at slope and slope shade, we looked at aspect and 3-colored aspect mapping along with slope shade mapping, and then we looked at contours. And all those different derivative products can be very useful for your mapping of landscapes and other sorts of things. So hope you found that useful.